Okay, so hello everyone. Welcome to the very first video of the series Designing the Best Thermal Management System in the World, Chapter 1. So, by the end of this series, actually, we aim at developing the best thermal management system in the world. So, okay, let's go to the Chapter 1. The Chapter 1 is the need and the existing systems. Okay, so why do we exactly need a thermal management system for a battery? Let's check that. Okay, so I have a screenshot over here for you, and you can see this that it has a date of 8th July 2020, and I'm making this video on 10th of July 2020. So basically, this is a screenshot of an article which read Scooter Blaze Moms issues stark warning after son scooter bursts into flames as he charged it, and she begs others to be aware. Okay, so you can actually see a better image of the same. This is an electric scooter which has a battery obviously and is burning. So let us read what the mum has to tell us about it. The mum claims her son found a scooter emitting smoke after being left on charge. Moments later, it caught fire. The fire crackles and billows out clouds of grey smoke as the woman and her family watch on from a safe distance. Captioning the video, the woman explains how her son had left this electric scooter on charge in the house. Luckily, he noticed the electric scooter smoking it before it went into smokes. This is obviously something which is very undesirable and could have resulted in something very dangerous. So what was the exact reason for this to happen? Let us check it out. The reason for the same is something called as the thermal runaway. So now I'll be telling you something about thermal runaway. Okay, so thermal runaway in a battery occurs when the internal heat generated exceeds the expel rate, the heat expel rate. So what actually happens in this phenomena is that this thermal runaway is going to trigger a chain reaction, and this chain reaction is going to happen in a period of milliseconds, a few milliseconds, in which the temperature inside the battery is going to rise between 400 degrees Celsius to 600 degrees Celsius. And this is going to result in something which you just saw in the screenshot of that particular scooter. So why does a battery actually heats up? The answer is quite simple. If you look at the internal structure of the battery, you will get to know there's an internal resistance in the battery. Obviously, this is something I'm naming as R-int. This is the positive terminal, this is the negative terminal. Okay, so, and this is basically the part which is going to provide the EMF of the battery. Okay, so the heat which is going to be generated because of current which is going to be withdrawn from this cell is going to be I square R times T if we are talking it in terms of a particular time period. Okay, so this I is basically the withdrawing current rate, okay, or the discharging rate, basically what we actually talk in terms of the EV language. And R over here is going to be the internal resistance. Obviously, when current moves through a material, heat is dissipated, and this is something which obviously happens in cells as well. Now if I look around the causes, that why is something like that happening, what are the causes? So the causes majorly involve around 3 to 4 reasons. Number one, the number one reason is internal short circuits. Okay, and due to some mechanical impact or accidents, some internal short circuits might occur. The second reason is the external short circuits. And deformation of the battery cells causes an external short circuit, basically, which is also going to happen in accident or something like that. Number third is, and which is the reason in most of the cases, overcharging. When we overcharge the battery above the limit mentioned in the data sheet, something called as thermal runaway happens. And number fourth is when excessive currents, obviously, as I told you that the rate at which the current is going to be withdrawn, if it is very high, then also we are going to experience thermal runaway. So these were the reasons why something called as thermal runaway actually happens. Okay, so now we have seen that thermal runaway is a phenomenon which basically initiates a chain reaction inside the battery and the temperature rises very rapidly. And that is something which is obviously undesirable. But then what do we actually desire? What is the temperature range we desire inside a battery? The temperature range which we actually want should exist inside the battery is somewhere around 20 degrees Celsius to 40 degrees Celsius. This is the range which we desire. So for keeping up this range, what do we need? There are going to be two cases. If we are having REV in a cold country, and second, in a hot country. In this particular case, we need to increase the temperature of the battery pack to get it into this range. But if we talk about the second case scenario, which is something we expect in India, we will have to decrease the temperature to bring the battery pack inside this particular range. Now, how can we do this? What are the various ways in which we can actually achieve this? For this, the existing methods are: number one, air cooling; second, liquid cooling; and this particular part can also comprise a combination with heat sinks. Okay, so let us now look at air cooling first of all. Okay, so what you have in front of you is something called as the air cooling thermal management system for a battery pack, right? So every part in any system has a specific application to perform, right? So if you look around the front part of this system, we have a front board, right? This has some holes in it. This is actually going to allow the air to enter inside. Then we have some cooling fans. What they're going to do is actually pull this air inside and push it to the battery packs, and this is going to pass through the gaps inside the battery pack, and then this air is going to pass out of the system through the backboard. So now we also see that we have this whole metallic shell around, right? This metallic shell around. So the application of this metallic shell is to protect from external short circuits, right? And now if I look at these thermal pads, these are actually doing two things: providing insulation between the lower and upper part of the battery pack and the outer metallic shell. So this is actually going to provide the insulation between them, and this is going to protect the battery pack from internal short circuit. Protect from internal short circuits, right? The second thing this thermal pad is performing is it is actually having high thermal conductivity. Thermal conductivity is nothing but the ability of a material to conduct or transfer heat, right? And it is denoted by K. So greater the K, greater is going to be the heat transferability rate of the material, right? So now if I look around, this thermal pad is actually having some high thermal conductivity and is providing the insulation as well. So the heat is going to be transferred to the metallic body and is going to be distributed in the metallic shell itself. This is actually going to cool down the battery pack a bit, right? And now if we consider this whole system as a whole, this is actually going to lower the temperature, obviously, but on some drawbacks as well. Like the first major drawback of this system is that, this air is entering inside the battery pack from the surrounding, right? But this air is also having the temperature of the surrounding, basic thermodynamics, right? This air is having the temperature of the ambient surrounding. Therefore, we cannot reduce the temperature of this air, which is responsible for cooling the battery pack, below ambient temperature. That is the temperature of the surrounding. We cannot reduce the temperature of the air, which is responsible for cooling the battery pack, below ambient temperature. For example, if you are in India and the ambient temperature is around 43 degrees Celsius, and therefore this air is also going to have the same temperature, that is 43 degrees Celsius, but we know that the optimum range of operation of lithium-ion batteries is in the range of 20 degrees Celsius to around 40 degrees Celsius. Therefore, this temperature is simply not advisable to be provided to the battery pack. The second part is the second disadvantage is that this system is actually not providing the homogeneous distribution of heat throughout the battery pack. When air enters in this battery pack, the air is cooler, right, as compared to the air which exits it. Therefore, when this must have passed this particular area, like the half of the battery pack, the air must have got hotter than it was before, and this hotter air would have passed in this second half of the battery pack, right? Therefore, the temperature of the air provided to the first half of the battery pack and the second half of the battery pack is not same. Therefore, the system is not providing. So we just looked around the disadvantages of this system. Number one being that the air which is being provided to the system cannot have temperature lower than the ambient temperature, and the second one being that this system is not able to provide homogeneous distribution of temperature throughout the battery pack. But this also have a very major advantage, being cheaper. And this is the reason it is used in most of the two-wheeler and three-wheeler electric vehicles which are running in India right now. So in my next video, I'll be talking about the current best model which is provided by Tesla and which works on liquid cooling for thermal management of battery pack. Thank you so much for watching.